Hey Mr. Harrison, it's Patrick here, and I'm going to be doing my lesson on the Desmos computer today, or on my computer using Desmos, and I hope you're okay with that. This is kind of how you did the lesson. You kind of graphed it out on the board and showed us how to find the equation doing that, so I'm going to try to replicate the same thing using Desmos. So let's just get right into it. What first I like to do is I like to find the max and the min of the functions because those are the ones that stand out to me the most. So 1 and -5 appear to be the max and min, so I'm just going to write that in here. And then with that, it's easy to find the sinusoidal axis. So I take 1 and add -5, or -5 and add 1, and I get -4, and divide that by 2 to find like the average or the middle, and I get -2. So it was -4 divided by 2, sorry, to get me -2. So I figure -2 must be my sinusoidal axis. So then once I get that going, I kind of just use like visual representation to say, okay, how many jumps does it take to get to, I know it sounds kind of preschoolish, but that's what I do. How many jumps does it take me to get to 1? Okay, 3. How many jumps does it take me to get to 5? Okay, 3. So the amplitude must be 3, and the sinusoidal axis looks like that's what it is. So like I said before, the A value, or yeah, the A value is going to be the amplitude there. So that's going to be 3. And I don't see any reflections or anything like that, so I assume it's going to be positive. And then using that with the sinusoidal axis, you can try to figure out, well, if I know it's going to be 2, what's it going to be easier to start on? The max, cos, where it's some number in between 1 and 0 and 1, or should I do the sinusoidal axis? Does that hit any good points? Well, it hits here right on -2, 0, -2. So I assume sine is going to be the easier one to do here. Now that we figured that out, we can kind of close that off just for now. And the d value is going to be the sinusoidal axis, which we already found is 2. So I'm going to plug that in there now. So basically, we got those all figured out. And now we just need to find the period and the horizontal translation. So the period is how long it takes for it to do a complete loop. So I see here 2, and then just after 3. Well, I know if this was a normal sine function, it would go to just after 6, because that is 2 pi, 6.28. So if I see here 6.28, this is when it does 2 full rotations in 6.28. So what if I divided this by 2? I would get 3.141 pi. Oh, look at that, pi. So then that's where it hits. So instead of this being, so it takes 1 pi for this to do a full rotation. Sorry, that was hard for me to get out for some reason. And a normal one takes 2 pi, so this must be being divided by 2. So the period must be being divided by 2, so that would make it, oh, sorry, I just realized I made a mistake there. The sign does not go on the inside. So this must be being 2, because it's being divided by 2. I hope that was clear. I don't know, I don't think I'm explaining it that well. But normally it's 2 pi, and it's just pi, so what we're dividing by is 2. So that's why that goes there. And then when you're looking for a normal, oh sorry, not normal, but the y equals sine x function starts on the y-intercept here and goes up and down and up and down. And this doesn't appear to have moved from that. So I would assume there is no horizontal translation. So I would assume this is the final equation. So we're just going to see if I'm right here. And yeah, for some reason these are in radians, but that isn't. That's just pi. Maybe am I not directly on 2? Anyway, so I'm going to guess it's going to be y equals 3 sine 2x minus 2. And then the equation I had here was y equals 3 sine 2x minus 2. So that's how you do it. I hope you accept this form of lesson. Like again, you kind of did the same thing. I just did it not as well. And I hope this works out for you. Have a good one. Bye.